In this brief lecture, we talk about temperature entropy diagrams. A TS diagram or temperature entropy diagram has its y-axis as temperature and the horizontal axis as entropy. So entropy and temperature, vertical axis temperature of horizontal axis entropy. The saturation dome, if we cover the phase changes of a pure substance, the saturation dome on the TS diagram looks similar to that of the saturation dome on the PV diagram, except that the slope looks slightly different. The top point is still the critical point of the saturation dome. Then to the left of the slope is compressed liquid, and this left slope is saturated line. The right hand slope is the saturated vapor slope, and to the right is superheated vapor. Now we need to learn how to draw process lines on the TS diagram. It's very often that we draw an isentropic process on the TS diagram, and for an isentropic process, the process line should be a vertical line on the TS diagram. For example, if you compress a saturated vapor, you start from here, somewhere on the saturated vapor line, and you go vertically upwards. This is if you compress a saturated vapor, and then after compression, this will give you superheated vapor. Okay, this is a isentropic compression. Okay, because we know isentropic process is adiabatic and reversible. For a reversible process, the heat involved is TdS. For isentropic process, this would be 0. Zero for isentropic process. And for isentropic process, if you heat it, if you compress it, the surroundings would do work to the system, which should cause the system's entropy or internal energy to increase. So a isentropic compression process should lead to temperature increase. Now, the other thing that we can see is if we have a process on the TS diagram. The area underneath the curve should be equal to the heat added to the system if the system is a reversible process.